everyone, and welcome to Virtualization. So, we are going to be talking about the advantages and disadvantages of virtualization for different resources, and we're going to be talking about infrastructure as a service and infrastructure as code, and how that is currently functioning on enterprise servers and in industry. So, the first thing that we can talk about is why virtualize. So, one of the most important things that has been noted in multiple surveys is resilience. Now, out after the pandemic, which I really shouldn't say after, we are still in a pandemic. 7 out of 10 companies have experienced at least one severe crisis. Remote work and work from home has also been absolutely huge during the pandemic. We've actually seen really large trends of jobs going fully remote or hybrid and continuing to work at home, which means we have to be able to have infrastructure to be able to support people working from home. We have to have scalable infrastructure and we have to be flexible. We also have a lot of automation because the pandemic has actually had huge hits to the workforce. Automation is something that we need to work with more so that we can get more done and be able to work with what we have in a way that makes more sense without needing to hire a lot more people. At this current time in November, there's about 2% of IT people do not have jobs, according to most of the studies that I've read, and about half of people are actually looking to switch jobs. What this ends up actually meaning is that companies are trying to hang on to people as much as possible, and they are not able to currently hire necessarily the way that they would like to and get people with the experience that they would like and get enough of them. So, automation is one of the ways we can deal with that. Now, one of the things that is probably going to be coming up next is AI and machine learning, and that's something that we'll probably be seeing more of in the future. Now, some virtualization and cloud statistics. So, the global server virtualization market is around 7 billion and is expected to grow up to 10 billion in the next 4 years. Desktop virtualization is predicted to be about 12 billion by the next 4 years. Something that's important to note here. The average hourly cost of critical server outages is between 300 and 400,000 USD in 2020. So that's something where companies are losing basically a lot of money when their servers go down. About half of companies' IT budgets are going to cloud services, and there's expected growth rates in global cloud application markets. So, some of the vocabulary that we're going to use for virtualization is host, that's the computer running the virtual machine, guest, that's the virtual machine, hypervisor, which is what's actually managing those operating systems. A snapshot is the copy of your virtual machine. You can think of it like a save state in a video game. And hardware virtualization. Now, when we actually have virtualization, so the sort of fundamental question, well, what is virtualization? So, when we have hardware virtualization, it means that we have a virtual machine acting like a regular computer. We can have full virtualization, which is basically a complete copy of hardware. Applications don't need to be modified. We can have para-virtualization and hardware-assisted virtualization. We can also have cloud computing. Now, virtualization is one of the things that has been getting more and more popular because it allows us to have multiple computers running on one set of hardware. So, if you are going to have, let's say, 3 or 4 servers that you are working on, testing for, developing on, stuff like that, rather than having 3 or 4 hardware servers somewhere, it's actually more cost effective to have a server rack with a bunch of things networked together and then use virtualization to decide which server is getting which resources. When we talk about the cloud, that actually gets I guess I would say, mixed in with virtualization a lot because basically the cloud is somebody else's computer. It's really all that means. So, cloud computers is where we have very large, very fast computers, probably data centers somewhere, and then we can access those computers in what they consider an on demand style way. So when we need the access, it's there, and when we don't have to worry about it. Now, everybody is using cloud computing at this point in time because if you have an email address, if you are storing files in something like Dropbox or OneDrive, you're using the cloud. It's really permeated all of our computing quite a bit at this point. Virtualization is what we have going on in the background of a lot of the data centers that we're seeing, a lot of the larger companies and the computers that they have running. Most of those are going to be virtualized, with some exceptions. Now, virtual servers. Some of the pros. There's smaller upfront costs. It can be cheaper. You can have the potential for on call support, and it can reduce in house IT staff. However, and there's a big however to this, virtual servers in the cloud mean that we can pay a third party to manage our servers. However, a lot of companies do have virtual servers in house. So we actually have really, really large companies and even moderately sized companies that are having virtual servers being done in-house. So it's really not reducing the in-house IT staff or giving us any extra help for on-call support. What it's actually doing is helping the scalability and reliability of our systems, and it is making it easier for our IT staff to be able to manage virtual servers. Now, physical servers. One of the things where we're still seeing physical servers being the winner is dedicated resources for what's considered mission critical systems. So, if we have, let's say, a credit card company with a mainframe that is processing all of their financial transactions, that is likely going to be considered mission critical. Credit card companies are not going to be happy if they can't process transactions and take our money. It just doesn't make them happy. So, we want to have dedicated resources for this. We don't want to have any resources fighting over each other. We just want one computer that does it, and that's all it does. Now, physical servers, one of the things that we could have a company that actually has a whole bunch of physical servers and they have virtualization on their physical servers. We also could have a company that only has virtual servers and they're hiring out for, AWS, Azure, Google Cloud, like that kind of thing. And so they're actually buying the virtual server access on the cloud rather than having it being done in-house. Now, there are some cons to both of these. So, when we have virtual servers, you're not necessarily in control of the physical server. Your physical server might actually not be anywhere near you. You could have physical servers somewhere completely different. Now, with global warming that's happening, one of the concerns is, well, let's say we are on the East Coast and we are renting a server on the West Coast. Well, the West Coast of the United States has been having a lot of fires, and so you could actually have your servers go down if you are running off of servers on the West Coast when they are in the middle of a forest fire. If you are running on the West Coast and your servers are on the East Coast, then, if you're in the northern portion of the East Coast, you might end up getting hit with snow. The southern portion, you might be getting hit with hurricanes, tornadoes, tropical storms. And so that can also take out your servers. Not necessarily something that you would notice because you're going to look outside and see sun, but because your servers are actually somewhere completely different, where they are can also matter. It also means that if something goes really, really wrong, you don't have access to the physical server anymore. So if you're running things off of a virtual server in the cloud, you can't just go and say, well, I'm just going to go do a hard reboot. That's not an option. You're potentially a plane ride away from your server. Now, physical servers do have some large cons as well. It can be a little bit harder to scale. Trying to add things into a physical server can be a little bit more difficult, which is why a lot of companies have started moving towards data centers. Physical servers also need dedicated space. Something to note here, physical servers generate quite a bit of heat. And so if you have a larger physical server somewhere, you actually have to take into account weather, temperatures, and cooling so that you don't have things melt or catch fire. You also have to have people that are responsible for the maintenance of the actual physical server. And when things go wrong and you need to replace stuff on a probably pretty regular basis, you need to make sure that you have that funding. So, those are just some things to think about with virtual versus physical servers. Now, let's say we want to manage our virtual machines in house. This is actually relatively common. Servers are considered, sort of investments. You are very likely to have servers with multiple cores, and if you're running more than one server in-house, virtualization makes it easier to manage them. Because then if you have, for example, a server rack, then you can have virtual machines, and you can really easily spin up a virtual machine for someone. You can have backup policies that are true throughout the whole company and write them so that you can back up those virtual machines and you don't have to worry about it. You're going to need to dedicate some hardware resources to your host, but not as many as you might necessarily think. And it makes it a lot easier when you have, for example, multiple people that need servers for different things. If you can manage them all through virtualization, it actually makes the infrastructure portion a lot easier to deal with. Now, one of the things that sort of do need to have a little note here, the caution that I have, um, small load machines, things not getting a bunch of hits, things that are not mission critical. Think about what actually is needed. Be careful of the law of averages. Think about uptime. Now, the reason that I mention this, a lot of servers will actually get sold with, let's say 99% uptime. Well, what that actually means is 99% of the time, that server is up and running. So if we have 100 days, 99 of those days, they are up and running. But one of those days, they don't have to be up and running and they will still meet their uptime requirements. So as I'm sure you can all do the math, if we have 350 days in a year and we have 99% uptime, well, that sounds lovely. That actually does mean that we potentially have 3.5 days that our server is down. Now, there are not a lot of companies that are going to be particularly thrilled with their server being down for 3.5 days a year if we consider that quite a few companies will lose up to or even more than $500,000 per hour that they are down. So you do need to sort of think about that and make sure that that resiliency is built into the systems. And that's actually one of the things virtualization can be really good for. We can get up and running a lot faster because if we have a snapshot of our virtual machine, we can automatically start pointing people to that snapshot of when it was working as we are troubleshooting what went wrong. So we actually don't really have that much downtime. So you can actually have it set up where you could have snapshots happening on a regular basis, let's say every hour. So if something goes down and let's say the server goes down, well, we can just spin up another virtual machine, point everybody to that, and then try to troubleshoot what went wrong on the first one. And instead of having 4 or 5 hours of downtime for troubleshooting, we have maybe 10 minutes at most because that's how long maybe it took us to sort of, realize the traffic went down and what was going on and the switchover. So things like that. There's quite a bit of software now that will help you manage your virtual servers. They are different varieties of popularity for different reasons and will depend on sort of what the company ends up needing. Now, if we were in class, I would have an activity, and the activity is that you are being tasked to figure out which software we should use. You don't probably have a team at home, but if you want to go take a little bit, make a list of pros and cons, and have a one-page executive summary, and just go look into these pieces of software and see what you find. Is it, easy to find documentation? Is it straightforward? Is it complicated? Um, so if you'd like to pause me and go do that and then come back. Now, when we have our virtual servers and our virtual server management, some of the things that we'll need to do is we need to make sure that we take snapshots. A snapshot is a exact duplicate copy of our virtual machine. So we would be able to go back to the snapshot if anything goes wrong. Migration means that we can actually move these snapshots. So if we are, for example, shifting providers or servers or anything like that, we can move these snapshots over somewhere else very easily, and then we don't have to worry about our systems going down. And then failover allows the virtual machine to continue working even if the host fails. So it will go back to the last working state, which isn't necessarily the point in time at which the failure happened. So it basically gives us not just some scalability, but also some reliability because we have lots of options for sort of fixing whatever went wrong and being able to get the company back up and running as soon as we can. And that as soon tends to be a little faster. Now, mostly the world has kind of moved on from nested virtualization, but you may or may not still see this. Virtualization inside of a virtual environment. We can actually have multiple layers of virtualization. However, at this particular point in time, most companies have actually moved on to containers, which is our next topic. And that's going to be a large topic because containers are very important for what is currently happening in the IT world. Now, infrastructure as a service. One of the things that we can actually do now is we can rent hardware or rent software. So let's say, for example, we want to pick up a server. So we could actually get a very reasonable server for $1,200, which if you buy gaming machines or anything, actually isn't that expensive. Couple of grand, we could get some server racks, things like that. However, maybe we actually don't need that much. So one of the things we can do is actually rent the hardware or software that we need for as long as we need it. So rather than having our infrastructure be done in-house, we can actually outsource that. So, an example of this, let's say you have a startup, and because you are a startup, you maybe only have 2 people working on it right now. And rather than having a dedicated server rack in somebody's house where you have to pay for the server, pay for the electricity, pay for the cooling, you can outsource it, rent some time on AWS, Azure, Google Cloud, whoever. And then you don't have to maintain it in house. And it makes it a lot easier for the people that are working on it to be able to get access. Now, of course, if we have a larger company, these costs can go up to the point where it actually doesn't make sense anymore to rent it. But it does allow smaller companies to host way more infrastructure. It also gives a more reliable billing schedule. So for some companies, they might not blink an eye at, $50,000, $500,000. But one of the things that companies do like is reliable billing. They like to have monthly bills, quarterly bills, annual bills, stuff like that. Most companies do not like unanticipated expenses. And so, infrastructure as a service can actually give us the ability to have a reliable monthly bill. So, instead of no bills and then all of a sudden a $400,000 bill because we have to replace our entire server rack set, we can have we're going to call this more reasonable, again, company enterprise level of reasonable, $100,000 a month. Infrastructure bill, and it's always going to be $100,000. So, and then we can scale it up and we don't have to worry about, what's going on with the hardware or buying more hardware or setting up more hardware or anything like that because we've got that very reliable bill. It also has reliability guarantees. So if you are renting infrastructure from a company, they are going to have reliability guarantees and uptime guarantees. An internal infrastructure doesn't necessarily have that. So it's one of the things that can sometimes make infrastructure as a service really popular. Now, there's a whole bunch of different places that do infrastructure as a service. So, the next activity that I would normally do is having everybody break into teams of probably two and make a list of pros and cons and a one-page executive summary and pick one of the following. So, if you'd like to go do this on your own, you can pick one or two of them, do a little bit of research, probably pick ones you haven't heard of before, and make a list of pros and cons for each of them. In general, there's not necessarily a, oh, everybody should do this option. It's just what ends up working for the company, the philosophy of the company, and if there's any rules the company needs to follow, such as, healthcare rules or financial industry rules, things like that. Now, the cloud. We remember that the cloud means just somebody else's computer somewhere. We can have different kinds of clouds. So we can have enterprise cloud, which is a cloud computer for a single company. We can have a public cloud, so that would be something like, Dropbox, where anybody can make a Dropbox account. And I'm not trying to advertise Dropbox in any way. It's just an example I think a lot of people would notice and know of. So we can have both of those. Now, one of the things that a cloud computer is able to take advantage of is economies of scale. So, if you have a company that is, say, doing a data center, they are able to negotiate better rates on a lot of their hardware or electricity or things like that just because of the scale of what they are buying. So, for example, if we were running a company that we knew we wanted to have cloud services, well, if it's an entire company and we have a company's budget, well, one of the things we could do is put in solar. That would reduce our electric bill quite a bit. We can choose how we do our heating and cooling system to make it more efficient. That can reduce our bills. We can negotiate with a particular vendor because remember, we're not buying one hard drive or two hard drives. We're buying 500 hard drives. So we can really do that bulk buy type of thing. Now, cloud services, if you are renting them, allows a monthly pricing or paying for services as you need them. So that gives a company the ability to buy exactly what they need instead of needing to overbuy. So if we have, let's go back to our example of a small startup. Well, a small startup with two people perhaps does not need that much infrastructure. But let's say that startup goes off for whatever reason. We could look at it as something like if everybody remembers the beginning of the pandemic and Zoom. Well, Zoom was actually a, smaller company at the beginning of the pandemic. And then when the pandemic happened and everybody had to move to video conferencing, somehow Zoom ended up being the sort of de facto video conference that a lot of people are using. So they had to scale up very, very quickly. And so they, probably had some surprise bills, but they were still able to sort of rent enough infrastructure that they could mostly reasonably support everybody that was wanting to use the service. And they were able to do that without necessarily needing to, pre buy a lot of hardware. Now, this as a service model and having this reliable billing and everything is actually really popular throughout industry. And you'll actually see a whole bunch of as a service models. Backend is a service, everything is a service, platform is a service, software is a service, all of those kinds of things, because it ends up giving us reliable bills, more reliable uptime, and easier scalability. Scalability is a huge problem in industry, and a lot of companies would much prefer to pay somebody else to deal with the scalability issue and just have their bill go up. Now, the next thing that we're going to talk about that's really important is infrastructure as code. So, when we talk about setting up virtual machines, we manage and provision computers. So, that means that we are going to have our virtual machines and we will need to coordinate them together and we need to give them resources. Being able to use code to give these machines resources and manage them means we actually have the ability to do this a lot faster and a lot better than if we just had people doing it. So we can have infrastructure as code for both physical resources and virtual machines and their resources. Other bonuses. Infrastructure as code means we can actually use version control. So, version control is the ability to save each version of our code and roll back or see what our code was every step along the way. Now, this becomes even more important when we have a lot of people working on it, but one of the things that's really nice about infrastructure as code is if we're trying something and it's an absolute failure, which happens, we can just roll back to the previous set of infrastructure and have everybody move to that very easily if we're using version control. We can also model the infrastructure with code. We can design it using software best practices. We can also share it a lot more easily. So if we have an entire infrastructure set up, we can share it with other people, other teams, other companies in a much easier way. We don't have to describe, okay, well, first we set up the virtual machine like this, and then we give it this amount of memory and that amount of hard drive. All of that's actually written as code. You're going to see this a little bit more when we get to containers and how containers are set up. So you can kind of think of this like recipes. If you think of infrastructure as code as a cookbook, and other people can follow the different recipes that we have, we are also able to follow recipes other people have already tested. So it's sort of helping everybody along. We can also have some reduction of cost because if our infrastructure is code, we don't really have as many setup and maintenance costs, and we have a much lower risk of errors because a lot of issues come from human error, and it allows us to do things other than just spend all of our time on infrastructure maintenance. So it's actually really nice for that because then we can basically just kind of say, code, please go set this thing up for me. And then the code is like, yeah, okay, I'm already ready for that. So yeah. So rather than saying, I'm going to go to the kitchen and bake some cookies, I can just say, okay, well, here's my recipe. And if my magic robot could just follow that recipe, that would be great. That's kind of the idea behind infrastructure as code and getting into how containers are actually working. Now, how to use and work with infrastructure as code. There's actually different ways of being able to approach this. We can look at what is our target infrastructure configuration. We could look at what needs to be changed from where we are to get to our target. We can look at how the applications are communicating and what relationships they have with each other. We can do things where the server will pull configuration from a controlling server. We can have a controlling server push the configuration. We could use different varieties of frameworks. And these are all things that DevOps and DevSecOps are actually able to work with to be able to get infrastructure that works for everybody at the company. It's also a way to be able to get developers more into the process so that they are able to say what they need better. So the people that are actually creating the infrastructure and doing that support can make things that are better tailored to the people actually working on them. So there's a lot of really good bonuses about infrastructure as code. Now, there's different ways that you can get your infrastructure as code done. So, for example, setup. What you need to have the system ready, such as what do we already want installed, what users do we already want, things like that. That some of the options are Chef, Puppet, and Ansible. Now, provisioning is when we set up our virtual machine, what do we actually need set up for this to be able to function properly? So, one of the examples here is Terraform. AWS can use CloudFormation. If you're using a different cloud provider, they probably have a provisioning setup that you can use. But the idea is all of these will help us so that when we are setting up our code, it actually takes us a lot less time. So we may have a larger initial time investment, but the overall time that we are putting into this isn't as heavy when we're using infrastructure as code. Now, normally I would have an activity here. This is another split into groups. Everyone's giving someone to research, make a list of pros and cons, and an executive summary. Pro-con lists and executive summaries are actually really important for industry. Being able to go through and pick which software or service or whatever it is that you end up wanting to use as a company and picking the right one for your company is actually a really important skill to have. So I would recommend going and looking through these options and just trying it out. Try making a pro con list. Try looking at how easy they are to use, the information that you can find, and an executive summary is absolutely less than 1 page, might even be a half a page. So that's something that you can go practice and is a really good skill to have. And from there, we are going to be talking about containers next. Containers is a very big topic, and it's something that's very important to what is going on in industry at this particular time and is a really hot job skill. So brace yourselves, containers are coming.